Oh, sorry. Sorry. I was mute. Sorry. So let me repeat what I was saying. I was saying that a control structure, even as you learned in C programming or in structured programming, a control structure is a statement of code that guides the flow of activities in a program. It's a block of code or a statement of code that guides the flow of activities in a program. And I was giving an example saying that if you are sent to the shop, you are told go and buy bread, then go to shop B and pick some grocery and come back. Now, when you are sent, you're going to follow a certain sequence of activities. You're going to move, buy bread, move to shop B, buy grocery, and come back. Basically, that's a sequence of activities. So, therefore, in a program, when we also would require that we guide how activities in a program flow, and therefore we use control structures in order to guide how those activities flow or follow one another from beginning to end. All right. Therefore, we use what you call control structures. They are the ones that are used to guide the flow of a program from one point to another, to another, to the end. All right. So then, when that is said, there are three categories of control structures. We can use sequence control structure, selection control structure, and iteration or looping. Okay. So let's begin with sequence control structure. Let's begin with sequence. Let's begin with sequence. So what does this involve? Now, sequence control structure basically, sorry, sequence control structure activities. Hope that you can see what I'm typing here. I'm using this as my board. Activities flow following one another from beginning to end without breaks of conditional tests. So activities flow following one another from beginning to end without breaks of conditional tests. In other words, uh, the activities flow and they follow one another from beginning to end, and in between there are no conditional tests or decision making. So normally, this is the way in which we normally represent sequence control structure. Uh, we normally just represent it using these kinds of things. So this is how sequence control structure begins. So we are just drawing a flowchart, all right? We are drawing a flowchart of a sequence control structure. It normally looks like, right? So inside here, we're going to say this is the start. I hope you all know what we are having, because in a control structure, you remember in structured programming, I think you did control structures at some point. You remember in the use of flowcharts, we use the ellipse, right? The ellipse to to show the start or the beginning of a program, right? And then you use the arrow to show the flow of data or the flow of activities. Use the arrow, right? So and then the last activity, so we're just using the boxes to show activities or computations, and then we have the last where now the program ends, where the program ends. So as you can see, these activities, okay, this should be stopped. As you can see, these activities are following one another in a sequence. It is not, the program is not breaking at any point to test a condition. All right. So an example of a program is if I tell you, and we have, in fact, all the programs that we've written, like last time we wrote some programs, all those programs follow a sequence control structure. For instance, if you are told develop a program that allows the user to enter two numbers, then computes and displays the sum of the numbers. The computer displays the sum of the numbers. Now, this kind of program, let me just call it example, yeah. So this example of a program follows a sequence control structure. Why? Because the program starts at some point, goes to an activity, goes to another activity, and goes to another activity, to another activity, then it stops. For instance, if we were to represent this, you're going to realize that it looks something like this. Using a flowchart, you're going to realize that it looks like this, like what we are having here. So the program begins, right? The program begins. So we shall have a start, right? So we have a start. So I'm just using the flowchart to show you how this works. So you have a start there, right? You have a start. Then it allows the user to enter two numbers, right? So if it allows the user to enter two numbers, then we will use a parallelogram to represent the what? The prompt, right? The prompt. I think we talked about the prompt last time, yeah? Output, user prompt. User prompt, enter two numbers. Yeah, so that is a display. That is a display. That is a display. Of course, you know that that's how we represent using flowcharts, right? And then when it prompts the user to enter two numbers, now of course the user should enter the two numbers, right? So user enters two numbers. User enters two numbers. User enters two numbers. Then what does, so we can call them A and B. And then what happens after the user enters two numbers? Computation. It computes. It computes for the sum, right? It computes for the sum. So computation of sum. So sum is equals to what? Sum is equal to A plus B. Right? And then when it does that, it now finishes by doing what? Display sum. So it now displays sum. Yeah? And now displays sum. And then after displaying sum, the last thing it does what? It stops, because now the program has ended. It stops. Right? See that? So now we put the arrows just to show the flow. So the arrows are the ones that are used to show the flow of activities in the program. So there is that. Then it flows. Just forgive me, the menu are not too straight, but of course they need to be straight when you're doing it. When I try to adjust it to be straight, you see the challenge I'm experiencing. So let me just have that. So you see how that flows. So the program flows from one activity to another, to another, to another, to the end. So as you can see, let me put an arrow here so that you can see what I'm talking about here. Look at this. So look at this. So the program flows from one point to another. So you see how I've put that arrow. The program flows from top to bottom without any break, or without any break and without any conditional statement. A conditional statement is where the program has to pause to test a condition. Then if that condition returns true, then it continues. If that condition returns false, then it continues on something else. All right. So in sequence, we don't have conditional tests. It's just activities following one another in tandem. Press shift when pressing another. Can see my what? How is that shift working? I'm having a difficulty, but anyway, I think you get the point. So basically, the point is there are no conditional tests. Okay, there are no conditional tests. The program just flows from beginning where we have start to stop. Yeah, start to stop, just flowing from beginning to end, right? So in the all the programs that we wrote in the previous class, they were all sequence control structure. Like, let me share this one that we had, the very last program that we had. The very last program that we had in the previous class was this. So this program was just a program that was supposed to do what? As you can see here, I want to have a comment. So I just want to have a comment, multiple line comment here. So what we are having here is a program. I hope that everybody can see this program here that we had last time. A program that allows the user to enter the marks of a student in 5 subjects: English, math, geo, science, chem. It then computes and displays the total marks and average, and also the marks for each subject. Okay, so that is what the program was. We are having for a student in. I'm cutting this so that you can have it somewhere here. It then computes I'm just trying to cut this so that they can all be in one page, so that for visibility. So this is what the program does, all right? So that's the program, a program that allows the user to enter the marks of a student in 5 subjects: English, math, geo, SWA, and chem. Yeah? Let's say the name N marks. Marks and of a student in 5 subjects. Name and marks of a student in 5 subjects: English, math, geo, SWA, and chem. It then compares and displays the total marks and average, and also the marks for each student, each subject. So basically, the program is just as simple as it looks. The program just does what? It allows the user first to enter it allows user to enter the name of the student and the marks he has scored in math, English, SWA, Chem, and geography. Okay. Then after it does that, it computes the sum or the total marks by adding all the scores or adding all the marks, and then computes the average by dividing those marks by 5. And after doing that, it displays the total marks, the average, the marks for the student in each of those subjects, and also the name of the student. So as you saw here, as you can see in this program, now this is a program. We just had a the program itself. So we had the program itself where we start with the preprocessor directive hash include iostream. Then we go to, of course, the main library, then the int main. Then we declare variables, okay? We declare a variable for storing the name of the student, a variable for variables for storing English, math, Chem, geography, soil, total, and average. Then we tell the user enter name of a student, then the user enters name. We tell the user enter marks for subjects. We tell the user math, the user enters math. We tell the user English, the user enters English. We tell the user chemistry, the user enters chemistry. We tell the user geography, the user enters geography, all the way. Then when he has entered all those marks, then it computes total, where total is equals to English plus math plus chem plus geo plus 1. And average is total divided by 5, because there are 5 entities. That's how you get average, right? And that is why we did what? That's why we declared using float type. Why? Because when it begins to compute average, there is possibility there is going to be what? Decimal places. So we want it to return only one decimal place. And therefore that's why we declared all of it using floats. Then we come and display the name of the student. We display the marks for the student in 5 subjects as follows: math inachukua math, English inachukua English, geography inachukua geography, chemistry inachukua chemistry, Swahili inachukua Swahili, total marks inachukua total marks, average inachukua average. And then it displays all of them. So again, as you can see, when we run this program, when we run that program, it does the following. So let me share the screen. So I'm sharing the console application for the screen. All right, there we go. So when it runs, this is the kind of output it will bring. So if I enter John Karaoke, enter marks for subjects: math 45, English 78, chemistry 67, 54. So I'm just pressing enter. When I press enter, it just goes to the next thing, okay? 28, press enter. So when I press enter, now it brings everything. Student name John Karaoke. Marks for John Karaoke in 5 subjects as follows: math 35, English 78, geography 54, chem 68, SWA 78, total marks 322, average 64.4. Right? So basically, that's how that program works. It's just a program, and so that's why I'm saying all the programs that we wrote in the previous class, including even the assignment that I gave in that class, they follow sequence control structure. In other words, the program does not break in between to test a condition. It just flows. Okay, so that is sequence control structure. Now let's now move on. Or is there anybody with a question before I move on now to selection? Any question in sequence control structure? The reason I've not dwelt so much in the code is because that code we studied it last in the previous class, so I don't need to go. That's why I've not gone through it in detail, because the code is already there. I actually shared that code in the system, so you'll find that code there. It is what we did in the previous class. So basically that is a sequence control structure. Now let's look at selection control structure. Let's look at selection control structure. Selection control structure. So as you can see now, I'm sharing my screen there. Selection control structure is where the program breaks, the program pauses at some point to test a condition or a set of conditions once before it proceeds with rest of other activities. A conditional statement. So a conditional statement, I'm trying to show you here, a conditional statement is one that returns true or false. A corresponding action or actions is taken when the condition returns true and when it returns false. Are we together? So basically, for instance, I can tell you, you as a person, I can just tell you, I want you to go to shop A and buy bread. If you don't find bread in shop A, then buy tea, tea bags, and come back. But if you find bread in shop A, buy the bread and tea bags and come back. Okay. So there you are going, when your activities are going to be guided by some conditions there, and the condition is whether there is bread or not. That is a condition. The condition is the presence of bread, the availability of bread. So if you go to the shop, you're going now to test a condition. You will ask, is there bread? If there is bread, you're going to buy bread and tea bags and come back. So that is the action corresponding to that condition which has returned true. Bread available, true, or bread available, yes. Then you will have corresponding actions, which is buying bread and tea bags and coming back. That's the corresponding actions because of that condition returning true. But if that condition returns false, like now bread availability false or no, then what will you do? You will buy tea bags and come back. So that is the corresponding action when that condition returns false. Are we together? So what I'm saying is that for selection control structure, there is condition is tested once. All right, condition is tested once. At every instance, condition is tested once. Right? Condition is tested once. It can be one condition. In other words, each condition is tested once. We don't test a one condition repetitively. We test one condition once. If there are multiple conditions, those multiple conditions, each of them is tested once, and then we move on to the next condition, and to the next condition, and to the next condition. Okay, then so let me now show us the different kinds of selection control structures we normally use in C++. So there are three. There are three selection control structures. There are three selection control structures in C++, and these ones are if else statements, nested if else statements, and what we call switch case statements. Okay, if else, nested if else, and switch case statement. Now let's begin with if else statements. so that we can now see the number of conditions in each. So we begin with if else statements. Now, how does if-else statement work? Right? So if-else statements, only one condition is tested. Only one condition is tested. Right? Sorry. Only one condition is tested, and of course, that one condition is tested. That one condition is tested once, as you can see here. It is tested once. So only one condition is tested. So how does if-else statements look like in a in a flowchart? If you want to represent an if-else statement in a flowchart, this is how an if-else statement will look like. So we will use a rhombus to show conditions. So inside here, sorry, inside here, this is condition test. Condition test. Condition test. Condition test. So that condition test, of course, you have done flowcharts again, as I said previously. I know you've done flowcharts before to show data flow. So we will use an arrow to show the flow. Right? These arrows are right. At least now they are straight. So we'll use that arrow to show the flow of data. Right? Sorry. That way. So this is data that is flowing from on top of the program, wherever the activities that are inside the program, it doesn't matter. But what matters is what I'm having here, right? So if the condition returns true, right? If the condition returns true, so here we are going to have true or yes. We normally have y for yes or true. And then if there's a condition returns true, then there are a set of activities, okay? Sorry, there are set of activities if the condition returns true. And if the condition returns false, so let me have another arrow. If the condition returns false, okay, that way. If the condition returns false or no, we normally use n for no, then there are other what? Set of activities. Set of activities when the condition returns false. So if bread is available, then the set of activities is what? Buy bread and tea bags and come back. Then if bread is not available, then buy tea bag and come back, right? So there is one condition. That is the significant thing about if else. There is only one condition. This is very key. Only one condition is tested. Only one. And that condition is just, in other words, there's only one conditional statement. And therefore, when that condition is tested, then there are a set of activities. All right? Only one condition is tested. Now, let us have a program. Let us have a program. Let us have a program for to show if else. All right? Show if else. Let's have a program. I hope that you are following. So, example of a program. Develop a C++ program that allows the user to enter any number. It then determines if the number is less than 10 it It then determines if the number is less than 10 or equal, is less than 10 or greater than 10. Greater than 10. All right, and displays the number is greater than 10 or the number is less than 10. Okay, so let's have that program. Very simple program. A program that allows the user to enter any number. Enter any number. It then determines the number if the number is less than 10 or greater than 10. Yeah. If the number then it then and displays, sorry, and displays the number is, so if the number is greater than 10, it will display the number is greater than 10. The number is less than 10, it will display the number is less than 10. Now let's show how this works in a flowchart. Let's show how this works in a flowchart. Now in a flowchart, this is how this program will work. Of course, I may not ask you in a C++ program to draw a flowchart. Why? Because you already drew flowcharts in C program. So here I'm just going to show you so that you can see the concept of conditional test using a flowchart. So look at this. So I'm having shapes here. So this is to start. So add start. Every program must start, right? After the program starts, it does what? It then prompts the user. So edit, insert shapes. I'm going to have that. So I'm going to add text. Use a prompt. A prompt is just a display. The way your phone tells you enter your PIN, that's a prompt. It's a display. Enter any number, right? Enter any number. So this is a display. This is how we show display using a parallelogram. I think you know that already. Just using that to illustrate this concept. So enter any number, right? So the user enters a number. That is output. So now this is input. User enters a number. User enters number. Right? Let's call it A. Okay. Then we now come to what? Decision, right? Or what we call condition tests, right? Condition test. Now let me just sorry. Let me go to the next so that I can show you better. All right, so there we go. So user enters a number. Then what do we have? A conditional test. A conditional test. So we use a rhombus for that. So we come here. So we have a conditional test. Is A greater than 10? You see, that's a condition. It's A greater than 10. In other words, it's the program is trying to test for condition in order to make a what? Make a decision. Is A greater than 10? So if A is greater than 10, then it has to do something. Now let me introduce the arrows so that you can see at least how the program is working, right? So let me introduce the arrows. Good. At least now I'm able to replicate new straight lines. Right, so all right, copy and paste. So you can see how this one is working. So these are the right. I hope you can follow through. And then we have an arrow here. And then we have our rhombus there. So for conditional test, of course, you have to arrange them. Let's see. Good. Then, okay. And then, of course, I need to arrange this. Good. So if A greater than 10, okay. If it is greater than 10, if that condition returns true, then it has to do what? It has to display. So display. So sorry. I need to at least. Yeah. That's how it should be. So if returns yes, the condition returns yes or true, right? Returns yes, and then you have yes there. If it returns true or yes, then it has to do what? It has to display what? It has to display uh, number A is greater than 10, right? And if if that condition returns false, in other words, it is a no. Let me have another line, another arrow. So if the condition returns false, in other words, it's a no, right? So if the condition returns false, so it's a no that way, then it should display what? Number A is what? Is less, right? Number A Number A is, I hope you're following. Number A is less than 10. Number A is less than 10. Then, of course, because the program has to end, then we copy and paste this. We bring it here and we change it to what? Stop. Yeah, it looks like that. And of course, we have our arrow here. So bring this arrow here, trying to show you how the conditional statement looks like, right? Then of course we have to have what? A line to connect this output to stop, because of course it has to stop at some point. So draw that way, and then an arrow. Can you see that? So that is how the flowchart for that will look like. Let me minimize so that you can see how it looks like, all of it. I think you can see it, right? So start, user prompt, enter any number, user enters a number. So after user enters the number, it goes into the conditional test. So ni wapi kuna if else? Hapa ndio kuna if else. Let me show you where if else is. So if else ni mali kuna condition. So mali unaona condition test, hapo ndio kuna if else, right? So let me show you, at least for them who need to see. This is now where the if else is. Okay. This is where the if else is. I hope you can see where I'm drawing. Hapo ndio if else iko. Okay. Can you see that rectangle I've introduced there? So that's basically to show you where the if-else structure is. Now that there is a condition test, there is a condition test. When that condition test returns true, it performs a certain action or set of actions. If that condition returns false, it performs an action or set of actions. Tuko pamoja hapo, right? So that is where the if-else is. Hapo ndio if-else iko. Okay. Now let us represent this program using a what? Using code, using C++ code, using C++ code. So let me now share the screen for code blocks so that we can now see the code itself. All right. Let me share that. I'm just going to create a new project. I think a new project is better because I don't want to delete this one. I don't want to, because I'm going to use it as the class continues. So let me create a new project here. I'm going to call it conditions. I'm going to be editing that conditions. So finish that. So my program is a .cpp. So let me have it that way. So the program first tells the user to enter two numbers, a number, but for the user to enter a number, we have to have a what? A number, right? A variable. So I'm going to declare a variable x, and then that variable x is the one that is going to store user's number, all right? I think you can see the comments. The variable x is going to store user's number. Then after storing user's number, we now tell the user. So cout, enter any number. Just that. Enter any number. All right. And then cin, sorry, cout should be that way, and cin should be that way, and cin-x, and then it goes into a what? So now this is what? Now this is what we call now the syntax for if-else. All right, the syntax. The syntax for if-else. So let me just revert here and go back and write the syntax for you, so that now when we write that particular line of code, you can now see it. So let me share this screen. Let me share back this screen. Let me share that. And then now let's see the syntax. Let's see the syntax for if-else. Syntax for if-else, right? Syntax for if-else. So the syntax is basically the structure. So if, this is how if-else works. If condition, so it tests condition, then it performs a certain action. It performs a certain action if condition is true. Action if condition true. Else, can you see the opening and closing curly brace? Else action if condition false. So this is the what? This is the syntax. So let me have it that way. This is the syntax for if else. This is the syntax for if else. This is how if else looks like. This is the syntax, all right? So now let me now go back to the code itself, so that now we use that syntax to write that code, right? So we come here. Let me share that screen. I hope you can see that screen. So here we are. So now we are at if statement. So if what? If x is greater, of course, We know that C++ is case sensitive. So if x is greater than 10, if x is greater than 10, then ukiweka tu opening curly brace hapo, ingine inajiweka. Okay? If x is greater than 10, then display cout. So x, right? X is the number, is greater than 10, right? Then end line. Else, can you see that how inajipanga tu yenyewe? When you arrange it, all the others it arranges for you. So cout. So else x is less than 10. Let's run this program and see if there's any error. That program doesn't have any error. So it has run. So let me share the screen. Let me share the console application. All right, so there we are. So enter any number, right? So let's add a number like 7. Can you see that 7 is less than 10? All right, 7 is less than 10. Let's run the program again. Let's have a number like, let's have a number like 12. 12 is greater than 10. Can you see that? Yeah. So that's how it's working. Let's add a number like 10. Let's add a number like 10. 10 is, let's see how 10 will behave. Let's add 10 itself. Can you see 10 is less than 10? Which is not true, of course. Sensibly speaking, 10 is not less than 10. 10 is equal to 10. But the reason it has brought 10 is less than 10 is because it's not greater. Yeah, it's not greater, so it will take the first condition, all right? But if we were to accommodate equal, then we would have to work with what? With a nested if-else statement. Okay? So then, so that is it about if-else. Now I want us to go to nested if. But if there is any question about if-else, please ask. Let me share the screen so that you can see and ask. All right, there we go. All right, ask any question that you have concerning if-else statement. Ask any question you have concerning if-else. Paul, Linus, Alvin, Bogonko, Bugwa, Hussein, everybody. Anyone with a question on if-else statements? Okay, then let's now go to nested if-else. Nested if-else statements. Nested if-else statements. Nested if-else. So let me go back and share the screen for our notes. All right, so now we are having nested if-else statements, right? Sorry, nested if-else, nested if-else statements, nested if-else statements. So, nested if-else statements. This is where there are multiple conditions, each being tested once. Multiple conditions each being tested once, and an action or actions performed when every condition, when each individual condition returns true, and an action or actions performed when each individual condition returns false. So nested if else, it's like an if, it's like a nested. Nested is a complex, okay? We can also call it a complex if else statement. So in the nested if else statement is an if else statement that accommodates for many conditions, and all of those conditions can return true or false, and each condition is tested once. So what is the flowchart representation? The flowchart representation for nested if else. I'm just going to pick this. So I'm going to pick this and then I'm going to copy. Okay. So copy this. Sorry. Just a minute. All right, there we go. So copy. Let me paste this because I'm just going to add some few things, not a lot of things. Nested if else. So I'm going to draw it here. So I'm going to insert an arrow and then show you how it works. Good. So this is how it normally is. So on a condition test, and then after condition test, there is another condition. Let me. This is how it looks like. So right. So let me have just trying to show that. All right. So the program just flows normally, and then ikifika mahali ita pause, it test one condition, then itapata hiyo condition tests. Let me put it that ndio itoshe hapa. So itapata hiyo condition haiko true, ama sorry, it's not, that condition is not. Now if a condition is true, it will do a set of activities. If a condition is false, it will test for another condition. So a condition after a condition, right? So copy and paste this. So it can be two or more conditions, right? So it tests for another condition. In that condition, returns false, it tests for another condition. Then, so here, yes. So if it returns false again, it can test for another condition. All right. So it has multiple conditions, but then I'm going to call this condition n. So this is condition test 1. Condition test 1. I'm going to call this condition test 2. And then I'm going to have condition test n. In other words, the last condition to be tested. So condition test n, right? The last condition to be tested. So if that condition returns true, then there are a set of activities that are performed, and if it is false, then it will end. Right? So this is how it looks like. Let's see how that looks like. course, it's fixed like that. All right, and then of course it will have what, a break. It will have to terminate somewhere. So it will have to terminate somewhere. So I'm going to have now an arrow to show that now there. And then it has to be like that. This, my line is not straight, but I think you get the idea. So there will be a set of activities, right? And also a set of activities again there. Right? So each one of it will have a set of activities, just that this to show up, but I'll just here this one will also have a set of activities there, right? Set of activities. So that's a no. And also this can be another no here, right? So I'm just that I can't have it there, but each one has to be indicated. So there are multiple conditions. There are multiple conditions that are being tested, and each condition is being tested once. Together, each condition is being tested once. Now let's have an example. Let's have an example where let's have an example where I will just replicate this question we had here. A program develop copy. Right, so let's have a, before you have the program, let's have the what? The syntax. The syntax. The syntax. The syntax is basically the structure. So how does it look like? It looks as follows. So we have if condition, then if that condition returns true, then action. If condition is true, then else if this way, else if another condition. So this is condition 2. So these I'd call it condition 1, right? Because there are multiple set of conditions. So else if, so action if condition is true. Action if condition is true. That way. And then we can even have another, let's call it condition n to represent the last condition, because we don't know how many conditions, depends on the program. So condition n is the last condition. Action if, so action if condition is true. Then the last one is else, not else if, else. And else is, of course, all of these, they are small case or lowercase. So else action if all conditions above are false, return true. Action if all conditions above return false. Return false. So this is the syntax for that. Now let's have a program. And the program, it's just the other program which we had coded just in a few minutes ago. We're just going to extend it, right? So we have a program here, a number which is less than 10 or greater than 10. We're going to add a functionality. Okay, so this is our program reads. These are program reads. Develop a C++ program that allows the user to enter a number. It then determines if the number is less than 10, equal to 10, acha niongeze hiyo functionality, equal to 10 or greater than 10, and therefore displays the number is greater than 10 or the number is equal to 10, or the number is less than 10. Okay, so how many conditions are we testing? 2. We are testing 2 conditions. All right, so why am I saying 2 conditions? Because of the following. Look at the code here. So let me share the code. So here is the code. So it's going to have one variable int x, which is to store user's number. Then we tell the user enter any number. He enters the number. So if x is greater than 10, see out that. Else if, can you see that now? Else if x is less than 10, all right, then we will say is less than 10. Else, naona else venye inakaa, so hakuna kuweka else if ingine. Okay, there's no other else if. So it is either greater than 10 or less than 10. Then if it does not meet any of these 2 criteria, of course it is equal to 10. So else, see out, x is equal to 10. So when we run this program, this is what it's supposed to show. So let me share. When you run that program, it's supposed to show that enter any number. Let's enter 7. You see 7 is less than 10, right? Okay. Let us run again and have any other number. Okay, there we go. Let's have a number like 10. So 10 should be equal to 10, right? Let me see that. So 10 is equal to 10. If we just enter 10, it just says 10 is equal to 10. Why is that? Because it has not met the 2 criteria. It has not met the criteria of x is less than 10. It has not met that criteria because 10 is not less than 10. It also has not met the criteria of x is greater than 10 because 10 is not greater than 10. Therefore, if it has not met the 2 criteria, then it meets it. It has met the third one, which is x is equal to 10. So there are only 2 conditions being tested, whether it is less or greater. Okay. So if it is not less and it is not greater, then it is equal. Okay. So that is what we are having. Now I want you to, let's have another program. So this program will read as follows. So let me share the screen. Develop a C++ program that allows the user to enter 3 numbers or to enter 2 numbers, okay? To enter 2 numbers. Develop a C program that allows the user to enter 2 numbers. It then compares whether, it then compares whether the first number is equal to, greater than, or less than the second number, then it displays an appropriate output. Okay, so develop a C program that allows the user to enter two numbers. It then compares whether the first number is equal to, greater than, or less than the second number. Then it displays an appropriate output. So it is a program where the user will enter two numbers. Then it will compare. Is the first number greater than second? If it is greater, then it has to display an appropriate output. An appropriate output is like 10 is greater than 20, or 20 is greater than 10, something like that. An appropriate output to show that that condition has been met. Or if the number is less, it says 10 is less than 20. Or if the number is equal, it will say 20 is less than 20. 20 is equal to 20. So let's have this program. Or can you do that program? I want you to have that program yourself. Code that program yourself, where the user enters two numbers. The user enters two numbers, then it compares the first number with the second. So it checks if x is greater than y, less than y, equal, and then it displays just like the first one. So do that program. If they are told there is a question, you can ask. So have that program, do that program in your laptop. When you are done, please say that you are done, so that I can now I can give you an opportunity to to present, to show us. So get busy. So do that program. When you're done, you can just type there done. Once you're done writing that program, you say you're done. So I give you 5 minutes, you do that. Is anyone done? You can see linears you've given us your code. Mhm. Yeah, linears, that's correct. The code is correct. It is correct. So
You are now unmuted.
All right. So the code that Linus has given us is correct. If you can copy that code to your code blocks ID and run it, it's going to give you correct output. Let me give you another question here, which now will end our class. So this is the second question. All right, the question goes as follows. Develop a C++ program that allows the user to enter the marks for a student in 5 subjects: English, math, geo, and swap. It computes it identifies the highest and the lowest subjects. It identifies the highest and the lowest subjects and displays. All right, so that's that's the program we're having here. So use nested if else. All right, so develop that program, develop a C+ program that allows the user to enter the marks for a student. The marks for a student in 5 subjects. It identifies the highest and the lowest subject, and then it displays. All right, work on that. So develop that program. I hope it's not just Linus that is doing this work and being active in class. I need everybody to be involved. I need everybody to be involved. All right, Justin. All right. So as you can see, I've used the logical and because I want to combine these conditions. If English is greater than math, and English is greater than chem, and English is greater than geo, and English is greater than SWA, then greatest subject score is English. Can you see that? Else if, so here we were testing English. That's why English ndio inaanza huku. Now we want to test math. If math is the greatest number. So if math is greater than English and math is greater than chem and math is greater than geo and math is greater than SWA, then greatest subject score is math. If this condition is not true and this one is not true, it will go to the other condition. Test the other condition to see whether chemistry could be the greatest number. So else if chem is greater than English and chem is greater than math and chem is greater than geo and chem is greater than SWA, then see out greatest subject score is what? Chem. If these conditions are not true, it goes ahead and tests geography. If all these they are not true. If geography is greater than English and geography is greater than chem and geography is greater than math and geography is greater than SWA, then it will display greatest subject score is geo. Okay, and if all these conditions are not true for greatest subject score, then it means the greatest one is SWA, so it will just display. So if English is not, and math is not, and chem is not, and geo is not the greatest subject, the greatest subject is what? Is SWA. Now let's first run this program and then now we'll now go into the other area of the list subject. In fact, list subject sitafanyia, nitawachia mfanye mmalizie kwa sababu utakuwa umeborrow hii idea. Okay, so let me share this screen here. Justin, the only thing that you have can see it is good. The only thing that you have wrong is you have used or instead of and. you have to use and so that it can be exclusive, right? You have to use and so that it can be exclusive, and instead of or. Okay, let me share this. So here we go. So now you see that. So I'll have enter marks for English, entire English 57, math 78, chem 89, geo 76, SWA 70. Can you see that? Greatest subject score 89, and 89 is chemistry. Yeah. All right. So now you will use the same scenario. You use the same working. You will use the same working now to work out what? To work out less than. So this one was to test which is the greatest subject. So now you will just do what? You just copy this one. The copy, paste hapa. So umemalizana. So this one. So let's have a comment here. Test for the greatest number. Test for the greatest number. So this one now is what? Test for the lesser number. Test for the greatest score. Test for the lesser score. For the least score. Then you just change what? You just change these operators inakuwa less instead of small inakuwa instead of greater than inakuwa less than. Just that. Yeah. Just come you change these ones here. Yeah. Change these ones there. Just change these ones. Just change the into less than. Just go changing these ones into less than. It will be testing for the lesser subject. Then hapo isema unasema the least subject score. Oh, and here you change into hapa ilikuwa less than, so hapo greatest, so hapo una change inakuwa least. Yeah. So hapo utasema least, the least subject score. But una change inakuwa least. Least. Then you run it. So when you run it again, it's there, it's run, so that means it doesn't have any syntax or semantic error. So let me share the console window for output. There it is. So let me enter random numbers: 90, 78 for math, 67 for chem, 70 for geo, and 57 for. Can you see that? Greatest subject score 90, least subject score 57. You see how that works? Let me run it again. Sharing the console window. So 78, 87, 36, 88. 67. Greatest subject score is 88. Least subject score is 67. Let me see that. So that's basically what was expected. So this is the code. Now I'm going to put up this code in the system plus other things that I will want you to do during the week. I'm going to put this in the system plus other things I'm going to require you to do during the week so that you can practice before we meet in the next class. So Justin, I can see, as I've said, the change into use the logical and, not the logical or. Okay, and also you have done well that you have actually mentioned the name of the subject. Math is the highest score, or Kiswahili is the highest score, or English is the highest score. You've done well. Yeah. Yeah. So then that's it. Anybody with any question, probably concerning the code that we've just attempted, or anything concerning today's lesson that you feel you need to ask? Any question? Okay, there is no question then. You can see many have participated very well, and for those who have participated, keep it up. For those who have not participated, I encourage you to participate because that's the only way that you can foster what you are learning. So we're going to stop at that for today. I'm going to leave some work and other instructions you to probably know about in the system. Also, for the sake of DIT, not DIT, for those who are attending research that is BDIT 2.1 and BIT 2.1. We are not going to have research methods class this afternoon because I need to do some things concerning your marks, your exam marks. The exam have to upload some marks that are required, so it's going to take me a while. So we are not going to have that class for research methods. So please also tell your colleagues that work for research methods. However, I'm going to have, at the end of the day, I'm going to leave some work there, which you're going to do so that you may not be idle, so that the class may not be as though it has been skipped, so that you may actually benefit even though you will not have it. So then you will tell your colleagues that we don't have research methods class, and that's there. I will give some work in the research methods part of the uni of the portal. I'm going to upload work for research methods which you can research on your own. So that is it for this afternoon. I hope that you have enjoyed the class and you've learned something. So in the next class, we're going to continue from there. Then, therefore, have a good afternoon and enjoy the rest of your day.